very long periods of time, essentially indefinitely. So bacteria can remain in these vials here, where we keep them as individual cultures. These cultures remain over time until they're required for fermentation, at which point we will transfer them to a hood such as this one. So what we're looking at here is a laminar flow hood, and this is an example of a piece of equipment that we utilize here to ensure that the bacteria we produce remain absolutely pure. So on the left you'll see a plate of bacteria which has individual colonies. Each colony represents one bacteria, and we use this to enumerate and to isolate our bacteria. From there we go into a small vial which we use to store in liquid nitrogen for long periods of time. And in each one of those vials is a single strain. That strain is maintained in our strain library, where we house over 100 different types of strains. From there we'll move on to the next flask, which is where we will inoculate into aseptically and go on to the next flask, and then finally an inoculation carboy. This carboy on the right will then be taken to our production area, where our large bioreactors will be used to ferment the bacteria over several days and produce the culture requirements for our products. So from there we'll go to our quality control lab and show you exactly how we do that.
Okay, great.
So we're here in our QC laboratory, where it's important that we ensure that all of our products maintain purity and activity. So at every point in transfer throughout the process of production, a sample's brought to the lab, and the technicians are responsible for taking that sample and analyzing it for purity and activity. Off to this bench here, you'll just see some of the plates that goes into testing the bacteria. On each of these plates are different types of bacteria that we produce here, and plates used to test for the absence of unwanted microorganisms. From start to finish, we go through about 100 plates for every single sample that comes through on its way to a final product. In doing so, we start from a single culture and go to the final product, which could take upwards of 30 days based upon the quality control time. So within this lab, the techs will continue working and go through all of these samples each day.
So it goes through over 100 quality control tests every batch that's made.
That's right. 100 quality control tests are required, and if it's not being done, it's simply not being done the right way.
What happens if it fails one?
If any batch within our process fails, it's immediately terminated. It's disinfected and sterilized, and then taken into the appropriate chambers and discarded. So now we'll go to our research and development laboratory, where we have technicians and scientists responsible for not only making our products, but advancing and developing our current processes.
Okay.
So this is our research and development laboratory, where our two primary purposes are to develop new products and to optimization on our current processes. One of the most important processes that we have here is our fermentation. So in the lab, we're constantly doing fermentation process optimization with small bioreactors such as these over here. It's a 2-liter bioreactor, which is used to optimize our media and growth parameters for our bacteria. And we also use it to scale up new different types of bacteria. You can see the complexity of the system, where we have to introduce different compounds throughout the run, and we can determine the different parameters of the culture throughout the run. So now we'll head out onto our fermentation area, where we'll show you the large-scale bioreactor.
Okay.
So this is an example of one of our fermentation areas, where we grow our cultures on a large scale. In these vessels, we can grow cultures in the hundreds of billions of colonies per mil. From this area, they will then go to a processing department, where they will be separated from the media component, and then they will go to a storage until they are approved for QC for final use.
Okay.